Hello, good evening to everyone. I come from university, so I will talk about educational data science. This talk is entitled Machine Learning Algorithms as Tools for Student Success Prediction. And the idea is to explore different data sources and apply various machine learning algorithms on the data to extract meaningful patterns and try to identify patterns in student behavior and identify a profile of the successful student. Please, in the introduction, just give me a few minutes to explain the context of the research. This talk is compilation of various research papers which were published at the scientific journals and presented at scientific conferences. And the papers were work of the group which works under the Laboratory LUIS, which is acronym for Laboratory for Data Mining and Intelligent Systems. And currently our main work is focused on the scientific project which is entitled SIMON, Intelligent System for Automatic Selection of Machine Learning Algorithms in Social Sciences. The idea of the project is to develop intelligent system which would recommend the best machine learning algorithm based on the dataset characteristics. The main drive of our work is entitled here, if you torture data long enough, they will confess at the end. So we have tortured educational data for various years in order to find some patterns in student behavior. This is the brief context of this talk. Basically, it is divided into three parts. In the first part, I will try to answer the question why this research is valuable to investigate it. In the second one, I will try to answer the question how did we perform research, and here I will explain research methodology. And in the third part, I will provide the answer to the question what are our results. Today, there are a huge number of machine learning algorithms which were developed in order to do some kind of data analysis. And they have the power to extract meaningful information from the data. However, the application of such algorithm is complex, iterative, and time-consuming, and there is a need to automate the selection of algorithm for the data. So the main question here is which algorithm is the best to be used in a specific situation based on dataset characteristics. This is the brief framework of the SIMON intelligent system that we are developing. So in the first phase, we are establishing dataset repository with hundreds of datasets from the social science domain. So we are focused on educational data and business data. Then we are extracting meta features for those data to see what are the characteristics of the data. And then we are applying supervised machine learning algorithms on the data in order to get metadata in which we will perform meta-learning and develop models for algorithm selection. Those models are the basis for our intelligent system. Here in this talk, I'm focusing on the educational data and application of supervised machine learning algorithms. Four approaches to the machine learning algorithms were used here. In order to perform analysis, we have followed CRISP-DM standard, which explains 6 steps which need to be performed in order to do knowledge discovery in data. Those steps are domain understanding, data preparation, modeling, evaluation, and deployment at the end. So my talk is actually focused on these 6 phases. Here I have enlisted research papers which have been used in this talk. And as you can see, mostly they are focused on educational data analysis. So in the first step, in the domain understanding step, which when it is performed in the research project, we are performing a literature review. So we have performed literature review on the given topic, and we have established the goals that we want to achieve by doing the data analysis. Our goals were to determine whether data from different sources, and here I will show survey, learning systems data, and YouTube analytics data. So we want to see, can this data be good basis for creating predictive models of academic success? Then we wanted to determine which of the variables used in the research are the best predictors of student success. And at the end, we investigated these predictions change over time because we had data from different generations of students. Recent research papers which are dealing with these topics identify various challenges which are enlisted here. So one of the topic of the research papers is investigation of various academic and non-academic factors which are related to student success. Then there is a topic of research methodology. Till now, mostly advanced statistical approaches were used in such researches. However, machine learning approaches are used in the last years. And of course, there is a topic of accuracy and reliability of such predictive models. In the data understanding, we have extracted various data sources. So we have performed surveys. We have used data from our learning management system. In our faculty and in our university, we are using Moodle as learning management system. And lately, in the COVID-19 pandemics, we have used YouTube, where we have posted links to the videos that were developed for the students, and we have integrated those videos at our learning management system. And here we have used YouTube analytics data to see what are patterns in students watching of that videos. First, let me show a little bit about the questions that were part of our surveys. I have here enlisted few questions. The survey was bigger. So here is the distribution of the students through generations. We have performed the same survey on the three generations of our students. So those are results from the students at the University of Zagreb. Then this is the distribution of their results at the entrance exam. And it is, as you can see, most of the students were somewhere on the middle of the list. And of course, the lowest number of students was at the top 10% of the rank list for the entrance. Next, we have taken a look at the first grade at the faculty. Various research papers which have been published have stated that first grade at the faculty is the best predictor of student success later, and it is also the result here at our research. Next, students were asked to express their level of agreement or disagreement with various statements regarding their perceptions of teamwork, how well do they manage time, and so on. Here is a statement which said, I manage time well, and as you can see, most of the students in our sample agree with that. Then I see myself as a responsible person. Also, most of the students agree with that. Here are the results regarding the statement, I find teamwork useful. As you can see, there is a significant number of students which neither agree or disagree with a given statement, so they are not all teamwork players. This one is pretty important, and it is statement I have prepared for the classes. As you can see, most of the students did not prepared for the classes. Why this is important? Because at our faculty, many teachers are using flipped classroom approach, which indicates that students should prepare for the classes, and as the name says, flipped classroom is that they should come prepared with the questions for the teacher. So it is really important, this aspect of the teaching process. So those were the data which were from the survey. Next, we have used a learning management system data. At our university, Moodle is used from 15 years now at LMS, as learning management system. Most, and in the COVID-19 pandemic, it was actually the main source. Here I have also enlisted various graphs to see what we take a look here. Here, first you can see, sorry, there are Croatian names on the variables. So here are students' grades. In our system is from 1 to 5. And you can see here the number of logs at the course, depending on the grade. As you can see, there is a linear correlation between the grade and number of logs. So students which had higher grades, 4 or 5, have or had higher number of logs at the learning management system than the students with the lower grades. Here we can see the distribution of students' logs at the Moodle based on the week in which the course was held. We have 17 weeks long course, and these two sneak peeks that you can see, which were in the 8th week of the classes and in 16th week, are actually the weeks that midterm exam was performed at the course, and there are also the highest number of logs in that weeks. Also, there are two smaller peaks at the 3rd and in the 12th week, and those were the deadlines for the assignments at the labs and at the course. Here we can see distribution of logs of the students based on the hour of the day, and as you can see, students are mostly at the learning management system in this time of the day, at the evening. We have here orange line and blue line, which represents the 2 days before the first and before the second midterm exam. This orange line is the day before the first midterm exam, and this blue line is students' activity at the learning management system the day before the second exam. And here we wanted to see, are there differences between male and female students? I have to mention that those are the students of informatics and economics. As you can see here, we can see dependencies of the number of logs, the grade, and the gender. As you can see, female students at our university had higher grades, but also they had a higher activity at the learning management system in average, of course. So that was a little bit about a second data source. The third one was YouTube analytics data. As I mentioned in the introduction, we have developed video materials for the students. They were posted at the YouTube, and YouTube links were posted at the Moodle learning management system. And here we want to integrate the data from the Moodle with the YouTube analytics data. Here are results of the correlation of the video duration dependent of the percentage of video views. This is this number here. As you can see, it is very high negative correlation, which indicates that the video which had higher duration had a lower number of views from the students. In our case, videos of about 10 to 15 minutes were downloaded, and students wanted to watch that videos, and videos which were prepared for the lectures in the duration for 40 minutes or 60 minutes, they had a lower number of views. Also, the second correlation, which is correlation between video complexity or complexity of the topic that was presented on the certain video with the percentage of video views. It was also a negative correlation. I have to mention that complexity is a subjective measure from the teachers at the course. In the data analysis, we have used 4 different approaches to the machine learning algorithms. So in some cases, we have used information-based machine learning algorithms. We have used various decision tree algorithms from that group. Then we have used similarity-based machine learning algorithm. As representative of that group, we have used nearest neighbors algorithm. Then as an error-based machine learning approach, we have used artificial neural networks, and we have used Bayesian approach as a representative of probability-based machine learning algorithm. I won't go into details of those approaches. I believe that you're familiar with that. All algorithms which were applied had the same goal. We wanted to use it to develop predictive models of student success. The difference between them is, of course, in the way they are perform learning. For some of them, I have enlisted here, I think, good sentences which are representative of the main idea how those algorithms work. So what we got as the results? Here are the results of sensitivity analysis, which was performed on the developed predictive models. And here you can see the ranks of predictors for the 3 generations of students. So in the Generation A and Generation B, high school grade average shown to be the best predictor of students' success at the faculty. And in the rank C, entrance exam result was the best predictor of the student success. For instance, this third variable, first grade at the faculty, which I mentioned that it has been a good predictor in previous research works, also shown to be important here. It is ranked as third most significant predictor of student success in all 3 generations of students. We have also used gender. As you can see at the bottom of this table, gender shown to be, it is not significant predictor of the success based on the machine learning algorithms. One of the research questions that were set up at the beginning was to see, are there differences in the different generations of students. In order to investigate that, we have performed a correlation analysis to see, are there linear correlations between ranks of predictor variables in different generations. And as you can see here, there is a strong positive correlation between predictors of academic success in generations B and C, and between generations A and B and A and C, those correlations are smaller. And we tried to explain that, and then we actually saw that generation A was generation that had a different education system. And between generation A and generation B, we have transformed to the Bologna system. So our conclusion was that predictors of students' success change over time, but only when there are changes in education system. Regarding the results of the learning management system data, female students shown to be more active on the learning systems, and they complete the course more successfully than their male colleagues. Overall activity on the learning management system is a significant predictor of academic success. And activity on different resources which were at the learning management system shown to be good predictor of student success at the course. To conclude, our research shown that machine learning algorithms can provide accurate and reliable predictive models. However, there are certain topics that need to be further investigated, and that which are listed here, and that will be part of our future work in this domain. So to answer on the research questions that were set up at the beginning, the first question was, are data from different sources good basis for creating predictive models of academic success? According to our research, the answer is yes, especially when we integrate the data from the different sources. We have also determined the variables which are the best predictors of academic success. So those are data regarding the first grade at the faculty, exam entrance results, and the previous knowledge they gained from high school. Also, learning management system activity shown to be good predictor of the success. And the last question was to determine whether predictors of success change over time. According to our results, there is change when there is a change in educational system. So, thank you very much for your attention.
Okay, so now we have time for a couple of questions. Do we have any questions? Yes.
Thank you. So my question is about this first grade at faculty. Is it always the same subject? For example, mathematics, which is the most difficult one, or is it maybe like sociology or something less difficult? How did you measure this? Because if I can recall my studies, even people who got bad grades at the end, they were good students because, I don't know, it wasn't so relevant in my opinion, so I was interested in this parameter.
Mm-hmm. Students were asked about their first grade, no matter which subject that was. Mm-hmm. So, for instance, for me, that was mathematics. For my colleague, was statistics or informatics, something else. So, it was students' first grade, no matter what the subject is. I agree with you. I was also very surprised with that. But as you see here, that was the good predictor, no matter what generation was it. So it looks like it is stable predictor, and it's also shown to be good predictor in the previous research. I don't know why.
Okay, that's very interesting. Thank you.
Yeah, thank you.
Okay, any more? I mean, I would like to ask, what is the idea? What is the purpose of this research? What do you want to do with it?
We wanted to optimize students' path to the success. So we want to identify profiles of different students, and for each of the profile, find the fastest path to finish the faculty.
So you mean to adjust what they're doing?
To adjust process of learning and teaching for the particular group of students.
So how far are you from this advising? I mean, how far have you gone with this research?
We are applying some of the results of these models at our learning management system in particular, but there are much more to go. We are collecting the data. Those are research only from our faculty, so it is hard to generalize those results.
But are you sharing those data with students?
Yeah, we do.
And,
we are sharing results.
Yes, I mean, I was meaning the results. Are you like sending them notifications, like things like telling them, okay, I mean, you're below your possibilities, so you can improve or you can do this and that.
Exactly. That's what I meant when I said that we are using the models in the Moodle.
And what are the results of that? I mean, is it getting better?
This is actually the first year that we are applying that in
Okay.
academic year. So next year in the data science conference, I can present that.
You can present us with some proper data on your success. Okay, any other questions? No? Okay, Diana, thank you.
Thank you.
Thank you.